Hello and welcome to my channel, Rhino here. Today, you might have noticed that this is not an evidence for evolution video, and there's a reason for that. You see, YouTube has this wonderful thing that seems to be in charge of everything nowadays called the algorithm. And as a content creator, if I don't feed the algorithm, my channel suffers. So when I try to do something new that is not going to appeal to all of my regular audience, but might bring in new viewers, the algorithm just sees that my subscriber base seems to not be enjoying those videos as much, and then decides that all of my videos should suffer as far as promotion goes. And since the restaurant is now closed, I can't just tell them I need more shifts if YouTube doesn't cut it, so here I am, feeding the algorithm. I will continue the Evidence for Evolution series, but at a rate of about one per month rather than once per week, with most weeks having 2 of my regular videos. Patrons will still only be charged for 1 video a week. So with that out of the way, we've got a video from a channel called Islamophilic that has 3 simple questions for evolutionists. So let's take a look.
As you figured from the title, evolution is our topic today. Because atheists don't like the concept of being held accountable for their actions by God, they endorse the awesome idea of creatures mutating randomly till reaching a suitable state for their environment based on natural selection.
Okay, there's a lot wrong with that. This is yet another example of the classic us versus them mentality. There are plenty of people out there who accept evolution but are not atheists. In fact, I would be willing to bet that there are more people who accept evolution and are religious than people who accept evolution and are atheist. 81% of Buddhists, 80% of Hindus, and 77% of Jews all come before the 72% of the unaffiliated group. And the unaffiliated group, while surely containing atheists, is not entirely made up of atheists. There are an estimated 500 million atheists in the world. If 72% of them accept evolution, that's 360 million evolution-accepting atheists. There are about 488 million Buddhists in the world, 81% of whom accept evolution, for a total of 395 million evolution-accepting Buddhists. Continue adding up the numbers of religious people who accept evolution, and you might come to realize that there are more religious people who accept evolution than there are atheists total, including those who deny evolution. So this talking point that keeps coming up over and over again, that evolution is just an excuse to deny God and be an atheist, is just flat out demonstrably and utterly wrong. So please, for the sake of my sanity, stop saying that.
In fact, they've been pushing it so much that anyone who exposes them now is called stupid.
Well, speaking as a former young Earth creationist who considers himself to be reasonably intelligent, I can honestly say that I do not consider someone stupid simply for being a young Earth creationist. In fact, the more intelligent someone is, the easier it will be for them to engage in the cognitive exercises that allow them to continue to hold to a creationist worldview, in spite of the evidence against it, things like cognitive dissonance and motivated reasoning.
You probably also noticed their obsession with the words evolve and develop, even when they have no place in a conversation.
I very rarely use the words evolve or develop outside of my videos. The most I've ever used the word develop was from back when you had to take rolls of film down to the drugstore to get them developed. Kids these days will never know the pain of only having 24 pictures on a roll and then having to change it. You actually had to make sure that all of your pictures were something that you wanted to use one of those limited exposures on.
So for example, instead of simply saying that bears have fur, they tell you that they evolved fur.
No, if we're just talking about the bear's characteristics, we'll still say they have fur. If we're talking about where the fur came from, then we might discuss how fur evolved or developed about 220 million years ago, but that's the same for all mammals, not just bears. If we're talking specifically about bears, then we're more likely to say that they have fur. Also, fun fact, pandas are one of those neat little examples of evolution where we had trouble classifying them because they are so basal that they shared characteristics with raccoons, and they could very well have ended up being a closer relative to raccoons than to bears. But molecular studies have placed them in the bear category, so bears they remain. If evolution were not true, then there shouldn't be these fuzzy categories like this where it's difficult to decide which arbitrary category they fit into. There should be distinct, clear categories that are inviolable. But that's not how nature works, because evolution.
Birds don't have a social life. They evolved it.
I mean, every species that has a social life developed that trait through evolution, including humans. but I've never heard it phrased quite so awkwardly.
And things could get out of control if they catch you saying that gymnasts train for their stunts. Instead, you should say that they develop them one attempt after the other.
Does anyone actually get mad if you say that gymnasts train? I don't, and I don't know anyone that would. Why would you say that people get mad if you say that gymnasts train rather than develop? I mean, certainly training for a sport develops your proficiency at that sport, but that's not develop in an evolutionary biology sense. That just means you're getting better. I really don't understand what the issue is here.
But anyway, Mom told me that I shouldn't judge anyone before giving them a chance to defend themselves.
And I agree, up to a point, but you have now introduced yourself as someone who is willing to make sweeping statements about categories of people that you clearly know very little about. As such, I don't really feel the need to take you very seriously.
Let's ask these guys 3 simple questions and see if they can clear a few issues in their theory. We won't resort to tough ones, like where did matter and life come from?
Matter came from energy. Originally, the universe was one big energy soup, but because of stuff that happened during the Big Bang, some of that energy was converted into matter and antimatter. For reasons that we still don't entirely understand, they were produced asymmetrically, so as they eliminated with each other, a little tiny bit of matter was left over. This little bit of matter ended up being all of the matter in the universe. As for life, life is essentially a series of chemical reactions, and while the exact chemical reactions that led to the first thing that would qualify as life remain unknown, it can be fairly certain that it was a series of chemical reactions. Though sure, you can put Allah in there as the creator of life and the universe if you like, just be aware that every year as our understanding increases, his role will be just a little bit smaller.
Or embarrassing ones like why can't you create a living cell from non-living molecules until now?
Why is that embarrassing? It sounds like you're under the impression that this has been done, but it hasn't been done in quite the way that we would like in a demonstration of abiogenesis. We have made synthetic life in ways that we know would not have happened in nature, and we have made proto-life that behaves in very lifelike manners. But no, we have not created life from scratch in a lab yet. But why would that be embarrassing? The current state of human technology has no bearing on what happened in nature in the past. It was only recently that we developed the power of flight, so clearly flight couldn't be natural. That's the same line of reasoning. Our current technology level is completely 100% irrelevant to the question of how life originated, except for the fact that our understanding of the origin of life will advance as our technology advances.
As this would be too harsh on them, so we'll just stick to evolution itself.
No, those aren't harsh questions. I mean, sure, those are difficult questions, and I have drastically oversimplified my answers, but they're not harsh. In fact, asking questions like how did life originate and why is there matter in the universe have been important for scientific advances. If these questions are asked with a genuine desire to understand the answers, they are most welcome. But you are asking them with the hopes of getting a response that can be equated to "we don't know," so that you can then fill that gap in our knowledge with Allah, the answer that answers everything in the most useless possible way.
The natural order of the food chain has to begin with plants, since they obtain their food from the sun without the need to raven others.
Well, it would have been a slow process, not sudden at all, and there probably would have been several stages where early life used chemical energy rather than solar energy as its source. But sure, let's start with photosynthetic algae, since that's what dominated the Earth for most of the history of life.
Okay, now imagine that the first algae and diatoms suddenly appeared somehow and began to procreate. What should happen after a while? That's right! Oxygen should gradually fill the atmosphere so much that it kills all these plants.
Yes, which brings us to the Great Oxidation Event, which essentially was a rise in the oxygen levels as a result of photosynthesis that changed the atmosphere from a reducing atmosphere to an oxidizing atmosphere, and which almost wiped life out completely. But, as has been demonstrated in lab conditions with E. coli, life is rather good at adapting to new food sources, so I don't see any problem with life adapting to use oxygen at this point. Which then allows for a balance between organisms that use oxygen and organisms that discard oxygen as a waste product.
But for some weird reason, Mother Nature chose to start the so-called Cambrian explosion at that point, so that plant-eating organisms would absorb the excess oxygen.
No, the Cambrian explosion was about 1.8 billion years after the Great Oxidation Event. Temporally speaking, we are currently closer to the Cambrian explosion than the Cambrian explosion was to the Great Oxidation Event. So if at that point constitutes a period of time that spans 1.8 billion years, then you might as well say that humans live with the dinosaurs, because we are definitely within 1.8 billion years of them. And the plant-eating organisms didn't evolve specifically to use the excess oxygen. Rather, the excess oxygen allowed for the development of organisms that could use it for metabolism rather than expel it as a waste product. They would have evolved before the Great Oxidation Event, but there wouldn't have been enough oxygen to sustain a large population. As the algae that were oxygenating the atmosphere became more abundant, so did the oxygen. Then, as the algae died out, the oxygen-loving organisms began to increase in number until an equilibrium was reached where there were enough plants producing oxygen for these oxygen-loving critters, and there were enough oxygen-loving critters to turn the oxygen back into carbon dioxide for the plants. As creationists love to point out, natural selection selects for characters that are already present, so organisms had already developed that could use oxygen, but they weren't being selected for very strongly until the oxygen got out of hand, and then suddenly they were very much being selected for.
Hold on a second. Now that we have all those plant-eating animals that reproduce and eat the plants, shouldn't they quickly finish all the veggies and starve to death?
No, not really. Okay, so we're skipping over the first aerobic organisms that would not necessarily have eaten the photosynthesizing ones, straight to the Cambrian explosion. Let's ignore predators for now, even though they did exist at this point, because I feel like you're about to bring them up next with a Mother Nature decided to make predators to keep the plant eaters in check. So let's pretend that there are only plants and plant eaters. The plant eaters will reproduce to take advantage of as many of the resources as possible, but when the resources become scarce, the plant eaters start starving to death. When there are less plant eaters, this allows the plants to regrow and repopulate. With the now abundant plant source for food, the plant eaters now repopulate again, and a morbid equilibrium is eventually reached where the plants and plant eaters keep each other in balance.
Well, yeah, but fortunately, for some other weird reason, Mother Nature made some animal-eating organisms before that happened.
Yeah, realistically, animal-eating organisms would have evolved at just about the same time as the plant-eating organisms, so they were there the whole time. And guess what? If there was a surge in the plant population that led to a surge in the plant-eating animal population, then that would in turn lead to a surge in the animal-eating animal population. This would then lead to a decline in the plant-eating animal population, which would then allow the plant population to surge again. Once more, a morbid equilibrium is reached, where all three categories keep each other balanced.
So why didn't they finish them? Because Mother Nature also designed carnivores in such a way that they're not much stronger than herbivores, so that neither of them would completely wipe the other off.
No, it's not about strength, it's about resources. It takes more energy to chase down prey than it does to graze on a stationary plant. So a carnivore needs more energy to take down its prey than an herbivore needs to chase the grass. So it's not that the predator's strength and speed miraculously matched up with their prey, it's more that their prey's strength and speed had to keep up with the predators in order for the prey to have a chance of escape. But if the prey wastes too many resources on becoming significantly faster or stronger than the predators, then that puts them at a survival disadvantage as they would require that much more food to sustain them. So again, it's about balance.
Had predators been a bit faster, they would have eaten all the prey and soon starved to death. And had the prey been a bit faster, no predators would have been able to eat them.
But evolution is a slow process, so every time a predator gets just a little bit faster, it won't be enough to completely wipe out the prey. But it does put a selection pressure on the prey to get better at whatever it does for defense, be it speed, camouflage, a behavior like holding perfectly still, whatever. This results in an evolutionary arms race, which ends up with all of the different and wonderful mechanisms of defense and predation that we see everywhere today.
Causing them to take over the whole planet and consume all the green. Actually, for every creature, there is another which feeds on it in what seems to be like an impossible equilibrium.
No, it's not impossible, it's just balanced. And, while this does all sound very wholesome and new agey, it's not a nice balance. It is a balance based entirely on death. If one species gets too prolific, other species will suffer the consequences. When the species that it relies on for sustenance becomes too sparse, then the original species numbers will drop proportionally. There's a reason that an estimated 99% of species to ever have lived have gone extinct. It's not because they were maintaining a perfect balance with all the other species, it's because the quest for that balance is deadly and has killed more organisms than all human wars combined.
Did all this happen randomly?
It's not really random, no. If one species hunts its food source to near extinction, that is not random. If that prey species then has some mutation that lets it better escape its predator, the mutation itself is random, but the fact that the members of the species with that mutation do better at surviving and reproducing is most definitely not random.
Let's ignore what I just said for now and assume it was just an accident, okay?
No need to ignore it. It's not a problem.
It's known that virtually all gendered organisms need a mate with an equal number of chromosomes to breed. A handful of exceptions exist, like the horse and the donkey, but even then, almost all resulting mules are infertile.
Okay, but if a handful of examples exist, not all of whom are infertile, then it is a fact that organisms with different numbers of chromosomes can, at least occasionally, successfully breed with each other. But that's not really necessary, as chromosomal duplication does not necessarily impact that organism's phenotype or reproductive ability. So it is possible for an organism to duplicate a chromosome without it impacting the organism's normal life cycle, and there is now a significant chance that this extra chromosome will be passed on to its offspring. If this chromosome ends up having a beneficial effect, it will quickly spread through the population, resulting in a subspecies with a different number of chromosomes from the parent species. If it has no effect, then there is still a chance that it will spread through the population, leading to the possibility of mutation for new structures from existing genes in the now superfluous genetic material.
Now think of the very first 46 chromosomed creature which evolved. Let's assume it was a male, okay? Actually, I think he would have looked a bit creepy, more like this.
Well, I don't know about the first one being male, and I'm not sure why that's important. You never really clarify in your video, and it's impossible to tell how far back you have to go in order to find the first hominid ancestor with 46 chromosomes, but you're actually bringing up a really good point. Humans are distinct from the other great apes because 2 of the great ape chromosomes fused together to become our chromosome 2. This happened at least 750,000 years ago, but possibly as far back as 4.5 million years. We know that Neanderthals and Denisovans had the same fusion because we've mapped their genomes, but we can't go back much farther than that with genetic data. Some of the characteristics that distinguish humans from the rest of the great apes are expressions of genetic material found in chromosome 2, which is important for the development of our brains and gonads. So it is entirely possible that the evolutionary development that led to humans being a separate species was the chromosomal fusion that resulted in our chromosome 2.
Now, for this poor guy to become a dad, he needs a similar 46 chromosome female. But he's the first and only human on Earth, remember?
Evolution is not something that happens to individuals. It is something that happens to populations. It is possible that the fusion of chromosome 2 resulted in an individual that is unable to reproduce with others in its population, but it's also possible that it was a common enough mutation that some of them were able to successfully mate. It is also possible that the reproductive effects were different for different sexes. For instance, women with Down syndrome, which is the result of an extra copy of chromosome 21, are able to have children. There is a 35 to 50% chance that their baby will also have Down syndrome. Men, on the other hand, are usually unable to have children, though some exceptions do exist. Now, if we go back to our hypothetical past species, there's a mutation that is somewhat common in the population that results in the fusion of chromosome 2. This can potentially make it more difficult but not impossible for those individuals to reproduce with other members of their species, and it is also possible that reproduction is easier with others that share the mutation. This results in a gradual reproductive isolation, which, as I explained in my video on biogeography, is one of the most important steps in the evolutionary process.
It was a very tiny chance which caused his 48 chromosome parents to give birth to him in the first place.
Well, the mutation that eventually leads to Down syndrome, Robertsonian translocation, occurs in about 1 in 1,000 babies, so it's not incredibly common, but it's also not prohibitively rare. And it bears mentioning that Robertsonian translocation is when 2 chromosomes fuse, reducing the number of chromosomes, so this is exactly the kind of mutation that would have led to humans having fused chromosome 2. And the translocation itself is a silent mutation. There are usually no phenotypic or reproductive effects for a person with such a mutation.
One that's not likely to reoccur for thousands, if not millions of years.
Nope. Some specific mutations are quite common. Some locations on a genome are more prone to mutation than others, and some mutations are more likely to occur than others. As mentioned earlier, about 1 in 1,000 human babies born have a mutation that fuses 2 of their chromosomes and has no effects whatsoever on those children. That's not a huge number, but it's not tiny either. If the chance of winning the lottery were 1 in 1,000, I might actually buy lottery tickets.
By then, if he hadn't died of old age, he would have died of loneliness and depression. That problem isn't confined to the first 46 chromosomed creature, of course. The same applies to the first 48 chromosomed creature, the first 6 chromosomed creature, and even extends to some plants.
Well, as I mentioned, evolution happens in populations, not individuals. Now, I'm sure there have been instances of individual organisms having a different number of chromosomes from the rest of their population that resulted in them being completely infertile, but for obvious reasons, those aren't the mutations that propagate. As far as plants are concerned, they play fast and loose with their chromosomes all the time. They actually seem to be rather fond of duplicating their entire genomes. The organism with the largest known genome is a modest flower from Japan, the Paris japonica, which has 8 copies of its entire genome and is suspected to be an allopolyploid species, which means it has fused chromosomes from 2 different taxa. Pro tip: don't bring up plants if you're trying to convince us that changes in chromosome numbers are rare and detrimental, because plants just don't give a damn.
It's not enough for one nearly impossible coincidence to bring them to life, but a similar coincidence is needed for each and every one of them to bring them a mate at the same time and place. Otherwise, they'd very soon perish.
It depends entirely on the effects of the mutation. Sometimes, they will still be able to reproduce with other members of the same species and will silently pass on their mutation that way. So, no, they don't need a mate with identical chromosomes at the exact same time and place.
Let's forget all what's been said. I mean, nature works in mysterious ways, right?
Okay, I see what you did there, but yeah, nobody's appealing to mysterious ways here. Everything I have described is known to be possible because it has been directly observed. So, Allah creating everything to appear related on a big tree of life? Mysterious ways. Evolution by natural selection? Well understood with mountains of evidence backing it up.
What's even more interesting is that some creatures evolve simultaneously. Let's look at some examples. Woodland ants warriors are necessary for the survival of workers, which are necessary for the queen and warriors. So which of them was evolved first?
Well, you kinda answered that question when you were setting up this section. Remember when you said they evolved simultaneously? That's the answer. The exact method that led to the development of all the different castes of ants remains relatively poorly understood, but one thing is certain. They have developed multiple times independently. Fossil evidence suggests that ants started their divergence from the other Hymenoptera after the development of the queen and worker castes, so the common ancestor to all ants already had that distinction. Modification over time of these 2 castes led to the differentiation of still more castes, like the soldier ants. It has been proposed that this differentiation is a function of size. An ant that is larger will have more queen-like traits, and an ant that is smaller will have less. So the smaller ants that did the jobs that are better for small ants to do were more successful and differentiated into a worker caste, and the larger ones that weren't quite big enough to be a queen themselves became the soldier caste. Some ants have lost different castes, and others have developed similar castes but independently in a spectacular example of convergent and divergent evolution. And just a minor note, when measuring ant size, we're talking about their size in the pupal stage. It mostly correlates to their adult size, but not always. It is also worth noting that ant castes are not exactly perfectly differentiated categories, but rather a spectrum, with some ants being kind of in between categories. Almost as if they are all just ants of the same species and just do the jobs they are most suited for based on their individual characteristics. Also, individual ants transition between castes as they grow, so it looks as though their caste system is almost entirely based on size.
They must have evolved together at the very same time.
Yep. Evolution does not focus on one specific trait, develop it until it's finished, whatever that can mean, and then start work on the next one. The whole suite of traits develops simultaneously.
The crocodile that doesn't devour the plover birds which feed on the remains in its mouth and protect its teeth from decay. How did any of them survive at first without the other when both are hardwired to cooperate?
They are hardwired to cooperate because that's how they evolved. Again, it is unclear exactly how the mechanism evolved, but there are several hypotheses. I'm going to generalize because this is not specific to plovers and crocodiles. There are many species that engage in cleaning symbiosis. Initially, at least some of the client species, that is the species being cleaned, and some of the cleaner species would have been what are dubbed cheaters. That is, the client would pose for cleaning and then eat the cleaner, or the cleaner would feed on the tissue of the client rather than on the parasites or food stuck in the teeth. The proportion of cheaters in one population would directly influence the proportion of cheaters in the other population until a balance is reached. It is important to note here that this cheating behavior does happen. Client species have been known to eat the cleaners, and cleaners will often feed on the tissues of the client in times of parasite scarcity, and some species have even evolved to look like a cleaner species, but they only feed on client tissue. So yeah, it's not some perfect happy relationship, it's a very complicated balancing act. And then there's also the fact that all vertebrates have a reward feedback for physical stimulus, as in, at least sometimes, the client species allows the cleaners to do their work simply because it feels nice. Think of that time you ate popcorn and got the kernel stuck in your gums for hours, or sometimes days in the bad cases. How good did it feel when it finally came out? Even if your gums end up bleeding a bit, the relief is worth it. Well, those cleaners provide that relief for their clients, not to mention just the nice feeling of having freshly brushed teeth. Hell, there are places you can go for a fish pedicure where you can stick your feet in a bucket of fish-filled water and allow the fish to eat dead skin off your feet. And just as a PSA, I'd recommend against that. While they do usually transfer the fish to an individual tank so you have clean water to put your feet in, the fish are still capable of carrying blood and bacteria-borne diseases from client to client. The risk is somewhat low, but what it comes down to is the fact that the tool being used on your skin is one that cannot be sterilized because it's a living organism. I mean, would you let a barber cut your hair if they just rinse their scissors underwater instead of putting it in the barbicide?
Coming up with proofs for evolution is actually quite easy. First, you find a fossil of an extant species. Next, you find a non-extant species which resembles it. And so you announce discovering the missing link.
Okay, first off, I think you got extant and extinct mixed up. But second, yeah, if you find an extinct species that closely resembles both an older extinct species and a modern extant species, then the one that fits in the middle is probably one of the transitional forms of that lineage.
Just don't forget to draw a tree with some funny Latin labels. Alternatively, you can construct a human skull with an ape's jaw and put it in the museum for fun and profit. Or just fake some comparative diagrams if you're lazy.
Okay, so Piltdown Man was a hoax. Not sure how much profit would have been made off of it, but if scientists actually knew that evolution was false but were covering it up, there would not have been any reason to expose Piltdown Man as a hoax like they did. And when you say fake comparative diagrams, you're showing embryos, so I assume that's a reference to Haeckel having fudged the details of his own drawings a bit in order to support recapitulation theory. But there are similarities, and it has been photographically confirmed, as you so helpfully show in your own video, so I'm not sure what you hope to demonstrate here.
Instead of answering these puzzles, evolutionists would probably attack us with even more false claims, like Neanderthals weren't fully human, or 99% instead of 95% DNA is common between humans and monkeys. However, they always forget to say that we also share 60% of our DNA with chicken and that 75% of our genes has matches in worms. Yet you don't look like a worm, do you?
No, we don't look like worms, but we do share significant amounts of our DNA with them. Now, I'm not going to check your numbers, they don't quite sound right to me, but it would be above 50% for sure. If I recall correctly, it's 60% with bananas anyway. Do you know what this means? It means that the majority of our genetic code is responsible for extremely basic functions that are almost universally shared by all life. And given that it's identical and that there would definitely be more than one way to take care of these basic functions, the fact that it is identical is strongly indicative of common descent. So, thank you for proving my point. And just to address the one line about Neanderthals being human, they were human. They were a species of human known as Homo neanderthalensis. They were a similar enough species to us that they could breed with us. But they were definitely their own distinct species. That's it for this one. When I picked a 7-minute video to respond to, I assumed it would be a short response. Shows what I know. Today's comment of the day comes to us from William Westbrook, who says, "I'm sick of the term irreducible complexity. Absolutely nothing is irreducibly complex. This was on my Evolution Stole My Cookies video, where Eric Hovind insists that creationism is scientific and does not just rely on the God of the Gaps arguments. And then he brings up irreducible complexity as evidence for creation. I'm not going to say that nothing is irreducibly complex. I mean, I do agree, but until we examine absolutely everything, we can't be 100% 100% certain, though I'd say that we're somewhere around 99.9% certain at the moment. And even if we do find something that we determine to be irreducibly complex, at its core, what this means is that we couldn't figure out how it developed. In other words, it's a gap in our knowledge. So even if irreducible complexity were a real thing, it still amounts to a god of the gaps. Thanks for watching. Special thanks as always to my patrons, who are the little silver coins that keep Mrs. Rhino alive long enough to beat at least one level. If you'd like to give me unlimited one-ups, you can become a patron for as little as $1 per week over at patreon.com/vicerhino. You can also send stuff to my P.O. Box and find links to my social media and PayPal donation in the description. See you next time!